we're going to start doing multi-step inequalities. And just like we did with equations, these are following the same steps as before, but they just have multiple steps to solve instead of just one. So these are multi-step inequalities. Okay, and so I have a bunch of examples. We're just going to walk through them right quick. And the directions here say solve each inequality and graph its solution. So we're doing two things, right? We're going to solve and then we're going to graph the solution. And what that means is that we're going to be drawing it on the number line, which I will be doing in blue. Okay, so the first one is 3 is less than negative 5n plus 2n. Well, don't miss the obvious stuff, right? I can actually combine negative 5n and 2n because they're like terms. So if I combine those, what I have is I have 3 is less than what? Negative 3n, right? And then we're trying to isolate the n, so n is being multiplied by negative 3. So we're going to divide by negative 3 here and here, right? And so over here, these are going to cancel, which is why we're doing it. And then on the right-hand side, 3 divided by negative 3 is, of course, negative 1. Over here we have an n, but because we're divided by a negative number, we're going to flip the sign. So it's now going that way. So negative 1 is greater than n, or if we rewrite it and we just flip the whole thing, and all I'm doing here is I'm just flipping the parts, right? I'm just flipping the parts, and I'm going to say that n is less than negative 1. So there we go, right? And the reason that I flipped the sign there, going from this way to this way, is that I'm just rewriting the whole thing. So if the alligator here was eating the minus 1, we still want it to be eating the minus 1 right there, right? Okay. So n is less than negative 1, and it's not equal to, so we don't make it equal to, and we don't make it equal to. So it's just n is less than negative 1. So we look at our graph here, we find negative 1, and it is an open circle, right? Because it's not equal to. So it's not actually, negative 1 is not included. But n is less than negative 1. And so if n is less than negative 1, then it is all of this going this way, just like that, right? And then it continues to go forever. So that's our solution. Okay? These are going to get more complicated as we go, so okie doke. So 5 times the quantity 6 plus 3r plus 7 is greater than or equal to 127. So don't miss the obvious stuff. Obviously the r is in here. We could go about this a couple of different ways. I'm going to say if we look here, subtracting a 7. Now of course you could go ahead and distribute, but you don't have to do that. And I think it's just going to make our numbers larger than needs to be. So if I look here, if I subtract this 7 from both sides, this will go away, and then this becomes 120, and then I'm dividing by 5, so I know that that'll actually divide it. So you can do this, and I'll actually, you know what, I'll do this two different ways just to show you that there's more than one way to deal with these things. So I'll do one method. The first method I'm going to do is where I distribute. Okay, so the first method, we're going to have 5 times 6 plus 3r plus 7 greater than or equal to 127. Okay, and the first thing we're going to do here is we're going to distribute there and there, right? And so that gives us 30 and 15R and 7 and 127. Okay, so combining the 30 and the 7, I have 37 plus 15R greater than or equal to 127. I just combined 30 and 7 right there. So then subtracting 37, maybe you're starting to see how this is going to work. So then those go away, right? So 15R. I'm not switching the sign here because I'm subtracting 37. I'm not multiplying or dividing by a negative. So 127 minus 37 is going to be 90. Then I'm dividing by 15. Dividing by 15. So those cancel. And then I'm left with R. I'm not switching the sign here because the 15 was not negative. So R is greater than or equal to 6, because 90 divided by 15 is 6. So this is our solution, right? Now, I'll show you that. So this took what? 1, 2, 3, 4 steps. I think we can do it in fewer steps if we do it this other way. So here I'm going to write down the exact same starting problem. So 5 times 6 plus 3R plus 7 is greater than or equal to 127. Whoops, sorry about that. No, so it's the same starting problem. So what I'm going to do here is just subtract the 7. So I have 5, 6 plus 3R and 120. Then if I divide by 5, so that those cancel, then I have 6 plus 3R and, gosh, what is this? So this would be 12, 18, 50, plus 40. No, that's not right. What is it? Oh my gosh, what's 120 divided by 5? 24. Oh my goodness gracious. I get so focused on making the video that I can't think about arithmetic. 24. Okay. And then we're subtracting 6 and subtracting 6. So that those go away. And we have 3R and 18. And then we divide by 3. I guess it's the same. I guess it's 4 steps either way. And then, of course, R is greater than or equal to 6, which is exactly what I had over here. So either way you do it, you're going to get the same thing. And notice I just did different steps, but I got the same answers. Anyway, R is greater than or equal to 6. So on our graph here, we find 6, and this time we're going to fill it in because it's also equal to, all right, and it's greater than or equal to, so we're going this way, greater than 6. Okay, so there's our solution. Okay, R is greater than or equal to 6. Okay. Okay, so 9 is greater than or equal to negative 2m plus 2 minus 3. So don't miss the obvious stuff. I can combine those right there, right off the bat, right? So I'm going to have 9 is greater than or equal to negative 2m, and then plus 2 minus 3 gives me a minus 1. So now when I go through to add the 1, and add the 1 so that those cancel, right? Then I have 10 is greater than or equal to negative 2m. I'm dividing by negative 2 so that those cancel. And so 10 divided by negative 2 is a minus 5. Over here I have the m, and I'm flipping the sign. Excuse me. I'm flipping the sign because I divided by a negative. So it's now going that way. And because it was equal to here, I leave it equal to here. So now I can just rewrite this if it helps you see it easier. It kind of helps me see it easier sometimes, so nothing wrong with that. So I'm writing the m, and I'm writing the minus 5, and the alligator is eating the m. I have to flip the sign there. I just turn it around because I'm flipping the whole thing. Okay, so m is greater than or equal to negative 5. So if we look at our graph, we find negative 5. It is filled in because it is equal to there. So we fill it in, and it's greater than negative 5. So it's going this way. Okay, it's going that way. Okay, so here's another one. Negative 3 minus 6 times the quantity 4x plus 6 is greater than negative 111. So again, like I showed you on the first one, there's many ways to do this, but I'm just going to do these one way. You can do them your way if it's different, but as long as you get the same answer, then that's what we're looking for here. So I think that the easiest thing to do here is going to be to add 3. So if I add 3 to this side and add 3 to this side, then I'm going to have a minus 6, 4x plus 6. Okay? And then I have greater than. Minus 111 plus 3 gives me a minus 108. And then if I divide, see, you don't always have to distribute. I could have gone through and distributed. I mean, I could have distributed there, and I would have a different solution, but I don't have to do that. Minus 6, divide by minus 6. So these go away, and I have 4x plus 6. Notice that I don't even need the parentheses anymore because I'm not multiplying it by anything. I do have to flip the sign because I divided by a negative. And then negative 108 divided by 6 is going to be a positive 18. Maybe that's what I was thinking about on the last two problems ago when I was getting 18 instead of 24. So I knew there was an 18 somewhere in here. So now we're going to subtract 6. Right? And we're left with a 4x. And notice we're not changing the sign now. We're not changing the sign because we did not divide or multiply by this negative 6. We just subtracted it. So we don't change the sign there. And then 18 minus 6 is 12. And then if I divide by 4 and divide by 4 so that those go away, I'm left with an x, and this is not a negative 4, so I still don't change it, and a 3. So x is less than 3. X is less than 3. Okay, so here I'm finding this. There's my 3. I leave it open because it's not equal to. Oh, excuse me. I leave it open because it's not equal to, and it's less than, so it's all of this. Okay. X is less than 3. Okay. Okay. This is getting more complicated. It really just has a big mess is all. So a lot of times when you've got a lot of this stuff going on, you just have to make a decision and decide what you're going to do first. So I think that probably the easiest thing, since we have an n here, notice we have n's all over the place in this. We have an n, and an n. Right, so we got to get those together. And since two of them are already on the right-hand side of the inequality, I think the best thing to do is just get all the n's to the right. So in order to do that, let's go ahead and distribute right there. Let's do that. On the left-hand side, I have minus 5n plus 6. I have not done anything to change the sign, and here I'm going to have a minus 35n and a positive 42, and then my minus 6n on the end. Sorry about that. Okay, so now I can start combining terms. So if I combine this and this, the two n's right there, then I'm going to have minus 5n plus 6. Haven't done anything to change the sign yet. Minus 35 minus 6 is going to be a minus 41 n. And then I have plus 42 right there. Okay, so now if I add 5n, because I'm trying to get the n's over here, if I add 5n, so that these go away, right? So now I have a 6. I still haven't done anything to change the sign. Negative 41 plus 5 is going to be a negative 36n. And then I still have my plus 42. But if we're solving for the n's on the right, then I have to get rid of this 42 by subtracting it. So negative 36n, and those go away, of course. So 6 minus 42 is going to be negative 36. So then I'm dividing by negative 36. Maybe you already see what the answer is here, so that those go away. Negative 36 divided by negative 36 is 1. We are changing the sign now, and don't just jump here and go, oh, well, n is 1. Well, yes, but we don't know what the sign is, and it's because we divided by a negative, we are flipping the sign here at the very end. So there's that. Now if we want to rearrange this, just to make it easier to read, we can do this and put the 1 over here, and then the alligator is eating the n, so we're flipping it back there. So there's our solution. So n is greater than or equal to 1. So if we look at the solution here, n is greater than or equal to 1. Okay, so n is greater than 1. Here is this. We are filling it in, and it's greater than, so it's going up here. Okay, cool. N is greater than or equal to 1. Okay, here is another one. Another one here. This is pretty easy, actually. Just because it doesn't make really much difference in this case, let's get all the a's over to the right. So in order to do that, we're going to subtract 8a and subtract 8a, just so we don't have to rearrange it at the end. And so those are going to cancel. I have a, or excuse me, not a. What is 1a minus 8a? Well, it's minus 7a. Okay, and then minus 6. Haven't done anything here yet, and there's that. Now we're going to add 6 because I'm trying to get rid of everything else. So I have minus 7a. I'm not flipping this, and 15 plus 6 is 21. Divided by negative 7. Now I'm going to flip the sign because I'm dividing by a negative. So those go away. I have a, I have a minus 3, and I'm flipping the sign. So it's greater than or equal to negative 3. Okay? So a is greater than or equal to negative 3. So here's negative 3. Filling it in, and it's greater than. Notice that all these, I left out the odd numbered marks here. I'm just giving you the even numbers, but you can tell that it's in the middle. So a is greater than or equal to negative 3. Okay. Couple more problems here. All right. A few x's to deal with. So it's not going to really matter which way we do this. I'm going to recommend that we just go ahead and distribute. Might as well. Minus x, 7x, minus 14. Okay, I can combine those two. So I'm getting a minus x getting a 6x and a minus 14. Let's go ahead and get the x's over to the left, so subtract 6x. So those go away, and so we're left with, what, a minus 7x. I'm not changing the sign, and a minus 14. But I am going to change the sign now, because I'm dividing by a negative 7, so that those go away. So then x is now greater than, notice I flipped the sign, a positive 2. Okay. So if x is greater than 2, then we find our 2. We find our 2. Don't fill it in, and it's greater than. Okay? X is greater than 2. Here's one with all of this stuff going on in this problem. I think the best thing to do is just distribute and then combine where you can. So I'm going to distribute there and there, and I'm going to distribute there and there. You can do two distributions in the same step. So negative 6 times 1 is minus 6. Okay? Negative 6 times 7k is a minus 42k. 7 times 1 is 7. 7 times 6 is positive 42k. And all of that is still less than or equal to, negative 2. It's a long problem. Okay? So if we look at what we're getting here, we can combine a couple of things. I can combine the k's. I can also combine the constants there. If I combine my constants, I'm going to get negative 6 plus 7 is a positive 1. Negative 42 plus 42 goes away. And so notice that these actually eliminate each other. So I've just got the 1, and then over here I have a negative 2. 1 is less than or equal to negative 2. What? What? That doesn't make sense. So this problem, because 1 is never equal to, 1 is not less than or equal to negative 2. So this is false. So this problem has no solution. There's no version of, no number for k that would ever make this inequality work. So this has no solution. That's your solution, that there is no solution. Okay? No solution, because we got a false statement here. 1 is less than or equal to negative 2. What? That's false. Okay. I'm going to skip this last one. We're going to do 2 more. Okay. So again, you got a lot of stuff going on. I think probably the best thing to do here to get the p's over to the left, which is just a personal preference. I'm just going to do the distribution there because we got this p that's stuck in here. So that's going to give us 3p minus 9, and then we still have the minus 5p, and it's still all greater than minus 3p minus 6. So if I want to get the, I can combine those. So 3 minus 5 is a negative 2p, and I still have the minus 9, and all that is still all of this. We're not changing any of it yet. Now I can add 3p, right? So that those go away. Negative 2p plus 3p gives me a p, minus 9, not changing that, and minus 6. But now I need to add 9. So I'm running out of room over here. So p, I'm still not changing this, and the negative 6 plus 9 is a 3. So p is greater than or equal to, or excuse me, not equal to, p is just greater than 3. So we find 3, we find 3, it's an open circle, and it's greater than. Okay, open circle, because it's not equal to. Okay? P is greater than 3. And this will be our last problem here. Again, a lot of stuff going on, so probably the best thing to do is just do the distribution and then combine where you can. So I'm doing 2 different distributions there. So negative 2 times 2 is a negative 4. Negative 2 times negative 2x is a positive 4x. Negative 4 times x is negative 4x. Negative 4 times 5 is minus 20. And then that is all still less than or equal to negative 24. Okay, so notice here my x's cancel each other. Okay, and you might say, oh, this is going to be no solution. Not quite. You have to see it through to the end to make sure. So negative 4 minus 20 is minus 24, and that is what? Think about what this is saying. Negative 24 is less than or equal to negative 24. Well, it is certainly not less than itself. It's certainly not less than itself, but it is equal to itself, and that is what this is saying. Negative 24 is less than or equal to negative 24. So this is always true. Always true. So what does that mean about the solution? The solution is everything, because no matter what you plug in, it is actually going to give you the same 4x and negative 4x. They're still going to cancel, and you're still going to end up with this same statement, which is always true. Okay? So because they're all solutions, this is infinite solutions. Infinite solutions. And what we say is all real numbers. That is what we say. We call it all real numbers, or you can say all real numbers. This little r that looks like this with little 2 lines here is how we say all real numbers. So all numbers will work for this. You can plug in any number and it'll work. And so this is what your solution is to this kind of a thing, is all real numbers. Here's another one. I've got just a couple minutes left on the video. We'll just go ahead and do it anyway. So distribute there and there. Not I'm 28 minus 7x, not changing that. Negative 4 times negative 7 is a positive 28x, and then that's a positive 28. Okay, so if we subtract, notice we have a 28 on both sides, so let's just subtract the 28 and see what happens. So that actually cancels both of those. So minus 7x, minus 7x and 28x. So we got to keep going here. We got to see this through to the end. Let's try to get the x's over here to the left. So let's subtract 28x and subtract 28x. I think you'll be surprised as to how this turns out. So of course these go away. Negative 7 minus 28 is minus 35x. Okay, and then what is that? This is 0. The whole right side is 0. So then if I divide by negative 35, and again, you got to see this through to the end, okay? Divide by negative 35, then look what we have, okay? We have an x. What's 0 divided by negative 35? 0. But this now changes because we divided by a negative. So now it's going that way, okay? And lo and behold, we actually have a solution. It's not all real numbers. It's not no solution. We have a solution. X is greater than or equal to 0. This is why I wanted to do this one. Now I remember. X is greater than or equal to 0. So we go to our graph and we actually have a solution to plot. Here's 0. We color it in because it's equal to, and it's greater than or equal to 0. So it's actually all of this. So you would feel pretty bad if you had gotten to down here and you said, oh well, this is just going to cancel and the whole thing is no solution because it's 0. No, actually 0 is a number just like anything else, and we have a solution here that is actually all positive numbers. Anything greater than 0 and 0 itself all satisfies this inequality. So if you get to a situation where you think, oh, I don't have a solution here, but you don't actually follow it through to the end, you may be missing something very obvious and turn out with a solution that you may not have realized at first. So just be careful when you're doing these problems.